I'm Anil Kumar, sharing with you an excellent question from my subscriber. They are going to start calculus and they will soon learn integration. So this is just before, or we could say pre-calculus for integration, right? That is the concept. Basically, sum of series we will see in this particular example. The question here is, find the area using basic concepts, and we are given a situation. Series of triangles with height of 1 unit and the base starting from 1 unit changes half each time. I have purposely not given you the diagram. I would like to sketch it now so that you understand the situation better and you are in a position to appreciate the solution itself. So what we are given here is series of triangles. So let me begin from unit 2. Normally this triangle will be given to you, this figure will be given to you, but I'm trying to make it so that you understand how we got the figure. So from 0 we go 2 units, half of 2 is 1, half of 1 is half, half of half is 1/4, and if we continue this series we'll go 1/8 and so on, correct? So that becomes varying base for the triangle. So I'll call this on this axis base of my triangle, and this is along the x-axis, and along the y-axis let me say height, right? So we'll have height along this. We're talking about 1 unit, right? So 1 unit, let's say this is 1 unit height. So now let me sketch triangles inside this. So the first triangle has a base of 1 unit. So let me just sketch a triangle here with base of 1 unit. So the base becomes 1 unit. Do you see that? Now the base reduces to half and we have another triangle. It doesn't really matter where this vertex is as far as the height remains same for the area, right? You understand that part. So let me sketch series of triangles with reducing base. So every time it becomes kind of half of the previous one. So we could get many bases like this, kind of like this, right? Ultimately, you will get something like this. The idea is to find area of all these triangles, right? So what we need to find here is, so question is sum of area of all triangles, Is it okay? That is the whole idea. Now let us see how to solve such a question from basic concepts, which I'll teach you now. Basic concepts, that means all concepts which you know about. We'll begin with the relation between area of triangle with area of rectangle, right? Rectangle. How are they related? Area of triangle is half the area of rectangle. And do you have a clue? I can just make this, right? So what I get here is a rectangle. Do you see that? Now in this particular rectangle, my length is equals to 2 units, 0 to 2, and width is equals to 1 unit, correct? So that is 1 unit, the width, and the length is 2 units. So what is the area? So we get area of triangles, sum of all these areas is half of length times width, that is 2 times 1, and that gives me how much? 2 divided by 2 is just 1, right? And the units is unit square. Let me write down in red, unit square. So we get 1 unit square as the area of all these triangles. Is it okay? All these triangles. This is our very basic concepts. Let's go to the second concept. We learned about geometric series. Right? We learned about geometric series. So what we do here is use the concepts of geometric series to find the area. So what do we notice? We notice that the area of sum of triangles, so we say area, sum of area, we are talking about all these triangles, is equal to how much? This triangle is half, base, formula is, is let me write down the formula first. We say area of triangle is, we have already written here. So area of triangle is half base into height. Let me write down here. Somewhere in between, let's write down here. Okay, so in general, we know area of triangle is half base times height. Is it okay? So we're going to use this particular formula. So the sum of area of triangles is equal to, let me write down here, we can run through. So the first one here is half, base is 1 unit, and height is 1 unit, correct? So height is this height, okay, plus the next one here is half times half, since the base is half times, again plus 1, times 1, plus half, base is 1/4 now, right? Times 1/4 times 1, and so on, correct? And so on. It's kind of an infinite series. Do you see that? So it is an infinite series we have to add all the areas. So in general, we can represent this series as half, because half is constant, half times 1 can be taken outside, and inside we have the sum of 1 plus half plus 1/4 plus 1/8 plus so on. In this series, as you notice, value of A is equal to 1, R is equals to half, correct? And sum of a geometric series, infinite series, is what? Sum of infinite series, when it is a geometric series like this, is A over 1 minus R, correct? So we'll use this formula, and therefore we can say it is half of A is equals to 1, so we'll say 1 over 1 minus R, which is 1 minus half, correct? Or half times, we will do 2 minus 1, this half, 2 comes here, so it is half times 2 over 1, and that is 1. And with this geometric series also we find the same solution, correct? So we say that the area under the curve equals to 1 unit square. Now in calculus, what we are going to do is this sum, which is normally used for discrete, these are discrete numbers, right? Changes to the sign this, which is for continuous. So that is how we are going to switch from discrete to continuous, and I hope it forms a bridge for the concepts of integration. Right? I'm Anil Kumar, and I hope you understand and appreciate this very important concept. As you learned in calculus, two things we are doing. In the first part, we learned how to find slope of a tangent line along a curve, and in this second part, we will find area under the curve. Feel free to write your comments, share your views, and if you like, that would be great. Thank you, and all the best.